At the end of the topic, you will be able to explain the working of some of the domestic electric circuits, identify the use of an electric fuse, define electric power. The entire electric appliance in our homes work on electricity from the main supply. Electricity from the power stations is sent along power lines to houses, factories, hospitals, etc. We receive supply of electric power through a main supply, also called mains, either supported through overhead electric poles or by underground cables. The electricity board supplies electricity through the live wire that is insulated red, which is about 220 volts, and the neutral wire or the negative wire is with a black insulation is about 0 volts. In our country, the potential difference between the two is around 220 volts. The live and the neutral wires are brought from the main line of the pole to the meter board fitted inside a house. Here the live wire is connected to the fuse or a circuit breaker called the main fuse. The live wire from the fuse and the neutral wire are connected to the electric meter. Another wire called the earth wire from the meter is locally earthed. The two wires coming out from the meter are connected to the main switch. This is used to completely cut off the supply to the house. From the main switch, these are connected to the line wires. From the main switch, go to the distribution box where it is divided into two main circuits. One of 5 amperes current rating for domestic appliances such as bulbs, fans, etc. and another of 15 amperes current rating for appliances with higher power ratings such as geysers, air coolers, etc. The electricity from the main switch is distributed in the house by a system of wiring. These various branch lines carry electricity to each portion of the room through a fuse. Each appliance has a separate switch to on or off the flow of current through it. Different appliances can be connected in each separate circuit across the live and neutral wires. In order that each appliance has equal potential difference, they are connected parallel to each other. In order to prevent electric shocks, the metal bodies of all electric appliances are connected to the earth by wires. In a house, local earthing is made near the electric meter. The earth wire, which has insulation of green, is usually connected to a metal plate and is buried deep into the earth near the house, where it is surrounded by a mixture of charcoal and salt for making good earthing connection.
Any source of energy can do work when the energy is drawn from it. For instance, a cell or battery can execute work at a rate based on the electrical device connected to it. This work done is converted into other form of energy such as light or heat by the electrical device. The energy consumed by the electrical device is equal to the work done by the source. The rate of electric work done is defined as electric power. If the work done by an electrical device in a circuit in a time, then electrical power of the device P is equal to work done by time. The unit of electric power is joules per second. It is also measured in watts because 1 watt is equal to 1 joule per second. We can also relate power with voltage and current since work done by electrical device W is equal to VIT. Then power P is equal to VIT divided by T, which gives VI. Power is equal to voltage into current. Thus, unit of power is volt ampere. Hence, the amount of electrical energy consumed by an electrical device can be calculated by work done W is equal to power into time. The commercial unit of electric energy consumed is 1 kilowatt hour, called 1 unit. If a source delivers power P to an appliance having resistance R, the wattage of power consumed by the appliance is given by P is equal to I squared R, or P is equal to V squared by R, since I is equal to V by R. Wattage of an electrical appliance is defined as the rate at which electrical energy is consumed by it. larger unit of power are expressed as multiples of watt. 1 kilowatt kW is equal to 1000 watts. 1 megawatt is equal to 10 to the power of 6 watts. The commercial unit of electrical energy is kilowatt hour, kWh, and it is commonly known as unit. 1 kilowatt hour is the energy used in 1 hour at the rate of 1000 joule per second, or 1 kilowatt. 1 kilowatt hour is equal to 1 kilowatt into 1 hour is equal to 1000 watts into 3600 seconds is equal to 36 lakh joules is equal to 3.6 into 10 to the power of 6 joules. The energy consumption in industries, commercial establishments and households are expressed in kilowatt hour.